I want to introduce to you today Dometic's DG3. This is the first gyro stabilizer in our line of many future gyro stabilizer products. This model is suitable for boats in and around the range of 35 to 41 feet in length. Some of the features and improvements that we've set out to make here on our product really focus on some of the pain points that we've heard from consumers. So specifically, we've reduced the spin-up time on our gyro stabilizer significantly over the competition. We're able to reach full stabilization speed in around 16.5 minutes. That's about 3.5 times better than the leading competitor. And furthermore, we can achieve an unlocked state of stabilization in only 9 minutes. Some of the key technologies that have enabled us to achieve this drastic increase in stabilization speed performance include the fact that we have a dedicated lithium-ion battery for the gyro stabilizer. So this battery runs at 48 volts. It's around the equivalent of a Group 24 battery. And we will pull power from that dedicated battery in order to drastically reduce that spin-up time. So in addition to being able to spin up faster, we can also recapture energy from the flywheel during spin down. We're the first ones in the industry to really do this. So instead of the gyro flywheel being spinning down under its own drag, we're able to actively recapture that energy using the internal motor for the flywheel and spin down in around 16 to 20 minutes as well. So this is a game changer when it comes to sustainability and also having the ability to just enjoy peace and quiet at the end of the day when you get back from a long day of boating, not having to worry about leaving your stabilizer while you finish boating at the end of the day.
Additionally, as Noam mentioned, the fact that we're not allowing it to spin down over 4, 6, or 8 hours reduces the wear and tear on the bearings significantly. And speaking of bearings, we redesigned all new bearing systems specifically for this product. They're more robust bearings than anything else on the market, and we're spinning this at 4,700 RPMs, which is about half of the competition. So there's far less wear and tear on the bearings. So your bearing life is going to be about 3 times greater than the other gyro stabilizers on the market. Additionally, we use something called parallel path cooling. So instead of cooling one bearing and then cooling the other with the same coolant loop, which allows one bearing to run hotter than the other, and heat is the enemy of bearings, we actually cool both at the same time using 2 different coolant loops that are parallel path. So that allows us to keep them both at a nice cool temperature, extending your bearing life again 3 times those other ones on the market.
Thanks, Grant. So one of the other areas of improvement that we've implemented in our gyroscopic stabilizer is our precession technology. So there is an actuator which governs the motion of the flywheel within the gyroscopic stabilizer, and we've ported over our electric actuation technology that we use in our steering systems, which consists of a roller screw technology, which is a really low friction means of converting rotational to linear motion. That is contained within our all-electric actuator. So no more hydraulics, no more leaks. We're able to drastically improve the roll reduction of the unit using this technology. It's much more sensitive over a hydraulic solution, which means better roll reduction in a greater range of sea conditions. Some of the other benefits of the electric actuator is we're able to actively recapture energy from the motion of the flywheel while underway. So depending on the sea state, we can use that to drastically reduce the overall power consumption of the unit. It also lends some benefits when it comes to our controls and the performance of the overall unit. So we've got a demonstration over on the marina, on some of the boats at the marina today, where we're showing some of the benefits of our dynamic precession technology, and that includes the ability to actively cause the boat to roll on command. So obviously with steering and controls, there's additional benefits that we foresee with that technology moving forward. When we talk about current draw, one of the other main areas of improvement that we sought to make was reducing the power draw of the unit. So we've been able to achieve a 40% reduction in overall power draw for the unit, which means a lot longer running time for the average consumer who might be constrained by battery life on a unit, and for other boat builders, it means less batteries overall, even though we do have an addition of a dedicated lithium-ion battery.
Yep. Thanks, Noam. It's a good point. And as Noam mentioned, one of the other things with the electric actuators, we've eliminated the use of any hydraulics on the system. So what that has allowed us to do is to truly eliminate all regular scheduled maintenance. There is no hydraulic system to maintain. There's not even a pencil zinc in the heat exchanger. We're using an all titanium heat exchanger that allows us to not need a sacrificial anode. Coolant runs through and the seawater cools that. The seawater pump's even part of the scope of supply. So that allows us to eliminate maintenance out of the system. So really it is a maintenance-free, set it and forget it kind of system.
In terms of accessibility, we've already taken off the cover, but our goal was to make it much easier to access components within the gyroscopic stabilizer. So the top cover, Grant, maybe you can grab it there. You don't require any tools to remove it. It features a ball and socket design which can simply be popped off to access all the major internal components. Furthermore, if there was a need to remove any of the panels, all of the fasteners are captive relative to those panels, so they won't fall down into the bottom of the bilge in the event that you need to remove a panel. Other features that we like to highlight on the unit is we do have an integrated touchpad with a real simple control for spinning up and controlling the unit, as well as spinning down and engaging stabilization. The unit also features an HTML5 server, so it will work with all display manufacturers. Some of the other areas that I like to highlight is voltage input capabilities. So we're future-proofing the unit for 48 volts. It actually will natively accept 12, 24, and 48 volts in the future, greatly simplifying installation and serviceability in the future.
Yeah. One other thing I like to point out is that with gyro stabilization in general, a common complaint is that captains and seasoned boaters aren't used to, they like the boat to roll over. That's how boats are manufactured and built and designed, is to roll over on their side when you turn. And so our system actually recognizes that. So instead of keeping you flat through the turn and turning in a very different way than you're used to, our system actually recognizes through the yaw input that you're turning, and it allows the DG3 to fully lock and disengage and allows you to make your turn and re-engages after you exit the turn.
On the coolant side of things, we do run an internal glycol coolant loop, which interfaces with a titanium heat exchanger, as Grant mentioned. We need simple raw water cooling, which we also supply the raw water coolant.
Yeah. Thanks so much for checking out the Dometic DG3 gyro, and we look forward to seeing you here at the show.